Okay, good morning, everyone. Welcome to today's BPA Energy Efficiency webinar. We're going to go ahead and get things started. So I'll go ahead and introduce our presenters. We have Robert Weber. Robert is an engineering technical lead working to develop future utility incentive measure opportunities. And we have Kashmira McVeigh. Kashmira is the program manager for energy efficiency emerging technologies, where she focuses on bringing emerging energy efficiency technologies to market. And Kesh, I will go ahead and turn this over to you.
Thank you, Maggie. Hi, my name is Kashmira. I'm glad you guys joined us today by way of refreshing. I cannot see the chat, but the chat is being monitored. So please post your questions there. And I'm really excited to bring to you today this first in a series of webinars on heat pumps. Today is a level setting presentation. So for many of you, it might be refresh, and for some of you, it might be new. So I'm going to go ahead and move on. It's an introduction. Robert and I are here. As a quick outline of today's presentation, we're going to talk about, so why are we looking at heat pumps as Bonneville Power Administration, an introduction to the language we'll be using, the key components of heat pumps, and then take you through an opportunity to view a real-life case study. On to the next slide. So why heat pumps? So Bonneville began this journey quite some time ago, and we looked at it as an opportunity to kind of identify some technologies in an area where we were really lacking. For multifamily buildings, heat pumps, space and water heating take up the majority of the load. So water heating is one of the highest energy intensity uses in multifamily buildings. And when we began this journey quite some time ago, we really didn't have sufficient products to meet that need. And so Bonneville's resource program, as far as like what we needed to meet our regional loads, this was a technology that we really needed to focus on, was multifamily water heating in our cold climate. In addition to that, we needed to focus here because it provided resources in the morning and evening peaks when we needed it for our grid. So that's another reason why we looked at it. As we began this journey, at the same time, we started to seeing massive accelerated codes and reach codes in all electric codes in an effort to tackle climate change and decarbonization. So that kind of takes you left to right. Why is Bonneville doing it? Why is the region doing it? And why are we doing it maybe more globally, more nationally? So there's a bunch of reasons why we're doing it. So the market language around heat pumps. What is a heat pump water heater? So heat pump water heater really is a device that's taking the opportunity to transfer heat from one medium to another medium. And in this case, what we're looking at is we're talking about air source heat pumps. We're transferring heat that is around us in the ambient air and transferring that heat to water to heat up the water. And we may have heat pumps that do that in one fell sweep, which we'll call single pass heat pumps, or we might have heat pumps that do that in multiple passes, which we'll call multi-pass heat pumps. What you see here, and I'm taking a couple minutes to do this, is because we have space heat pumps, and we have space heating heat pumps, and we have water heating heat pumps. And we have residential heat pumps, and we have commercial applications. And so I want to be able to be really clear as we're level setting here today, the type of technologies we're talking about. So these we see on the left in the residential, we see a mini split residential heat pump. We see a residential integrated unit here. And then we see here on the right-hand side, a commercial VRF application and a commercial multifamily split heat pump water heating unit. So a little different looking than the residential units, but same technologies, and I'm going to walk you through that. So the residential system, very simple to see. One unit, one box, one package. Whereas our commercial systems may be a little more complex, but hopefully by the end of this presentation, you'll understand them. And we have a very clear definition for a commercial heat pump. A commercial heat pump is a system that serves, and a keyword here I should have it underlined in the graphic animated, is a system that serves 4 or more dwelling units or commercial loads greater than 120 gallons of storage volume and greater than 6 kW of input power. So that's a key definition of a commercial heat pump water heating system. And here's a picture of a system here. Our next slide. So we really have multiple types of products on the market. I like to say that there is a heat pump water heater for just about every type of application. We have integrated units we've seen. So we have the A.O. Smith and the Rheem here. Those can be used in residential applications, but they're also good for small commercial applications. These also can be used in multifamily applications. So I like to think that usually that we would think of a product and an application. But I don't think that's really the case anymore, because now with engineering and design, you can take a product and you can design that product in more than one application. So these type of units can be put together with multiple in a design and serve, gang together, we like to call them, and serve a multifamily application. But these 134A units don't work as well in colder climates, like in temperatures below 32 degrees. So that is one of the things you have to consider in using these. And what might be better in those type of climates is using a system that has a CO2 system, such as the Sanco 2 or the Mitsubishi units. So the Sanco's originally designed for, again, the residential applications. We've used those in multifamily applications by putting multiple together. And then the Mitsubishi unit, obviously a very large unit, we've also been able to use in a multifamily application, which I'm sure you'll see in the next slides coming up. The CO2 also has specific usage, which it operates well in. So it operates very well in the cold climate, but also requires cold water to operate efficiently, cold intake water. It doesn't operate as well when the water coming in is warm. And so those work well, as I said at the beginning, in a single pass, in a single lift, whereas the ones with the other refrigerants might work better with warmer water and multiple passes. And finally, we have, oh, so sorry, went too fast, go back. Finally, we have on the far right some split systems, larger units, the Colmac and the Nile, that work well in buffered spaces, or they have, like I said, they work better with warmer intake waters that require less of a lift and be good in a multi-pass type of situation. So there's multiple types of heat pumps. I think is the point of this slide. There's many more heat pumps that aren't shown here and many more heat pumps that are coming to the market. And I really just wanted to share with you that there's different applications, different heat pumps, and different pluses and uses for the different opportunities out there. Next slide. So I'm going to pause here, and I wish I could see the chat, but I would like you to consider in the chat these 3 questions here. So time to kind of wake up and get those fingers going. Either tell me one thing you've learned about these central heat pump water heater systems, something that remains unclear, or something else you need to engage with your customers or your peers, whether they be other people in programs, other utility customers, what other information you need. And Maggie, maybe if you're monitoring the chat, you can help me out here. And while you're typing that up, I'd like to point out a little side story here on this project, and I believe the Lighting Design Lab is also going to be doing a training on this project that was really fantastic. What you're seeing on the screen is the Bayview Tower. It's in Seattle City Lights, Seattle Housing Authority project, where the Mitsubishi system was delivered on a skid provided by Origin, built up by Origin Stethis, and that's the label you see on the outside. The storage units for the system are all in that shed. Think of like a big old tough shed. And the project was delivered on a semi-truck to the site with demand response on the system. And I think the whole system was down 3 hours for this install on this deep retrofit. And it's really quite an amazing project. So pause there. What do we have coming through on the chat?
This is Maggie. We have one response that says, and sorry, I'm not going to know what this acronym is. I learned CHPWHs come in many different configurations. And we have another response that says, yes, we will, December 6th, 2022.
Great. So that says central heat pump water heater systems come in all sorts of different sizes. And that's the Lighting Design Lab saying that, yes, we are going to have the training in December 6th. What about something still that remains unclear or that would be useful to engage customers? And I'll keep going. You guys can keep filling in the chat in the meanwhile if it comes to you. So what are the fundamental components? I use the keyword central heat pump water heater system. And we had a definition of central heat pump water heater systems. So now I'm going to talk about the key components of these systems. So again, residential system, easy. You buy it off the shelf. It all comes together with all the parts and pieces. You don't have to do any Lego guesswork. There's no instructions. A central heat pump water heater system, similar once you understand the key components. So first thing we have is the heat pump. Next thing we have is the primary hot water storage. Next thing we have is we have temperature maintenance. And then finally we have the controls. So for example, again, heat pump water heater, residential, 4 key components. On the commercial system, same thing. They're just spread out and bigger and more expensive. We have our, primary heat pumps. There may be multiple heat pumps that are out there. Might be one heat pump, primary heat pump water heater storage. We separate the temperature maintenance and the temperature maintenance heat pump. If there's required another heat pump for the temperature maintenance, that load, keep that separate from the primary heat pump load. And then finally, the controls, 4 main components of a central heat pump water heater system. There will be a test at the end that's graded. So primary heat pump water heater, primary storage tank, temperature maintenance system, and the controls. Those are the 4 key components of a central heat pump water heater system. So again, the residential system and a commercial system. This is a view of what we have installed in the Jackson apartments. This was put into the buffered space of the parking garage. These are Colmac units that were installed there. I can't remember if this slide is animated, so please excuse me. So we have the heat pump. Great, it is animated. The heat pumps that are here, we have the primary storage tanks here separated. We have the temperature maintenance system, and then we also have the controls on the back wall. And so a little bigger, a little more spread out, a few more pieces, but essentially the 4 main components are the same whether or not you're getting one piece of equipment off the shelf at a big box store for a residential, or if you're getting multiple pieces ordered for a central heat pump water heater system, or fortunate enough to get it on a skid delivered to the job site, which is what we're hoping to promote in our programs, to take the guesswork and the multiple designers and contractor tradespeople out of the complexity of the project. Okay, so for key components, I think we hit this. I hope I didn't go backwards. Oh, good, I didn't. So multiple types of primary heat pumps we saw again. So we can have, big units, small units, single pass, multi-pass, multiple types of refrigerants, primary storage, big tanks, secondary storage system, again, more tanks, different types of heat pumps used to maintain that secondary storage. It's going to have to be something most likely other than CO2 because CO2 is not going to work efficiently in that secondary recirc lift loop. And then finally, the control panels to maintain those controls. Pause here for that test. What are the 4 key components of a central heat pump water heater system? Let's put that in the chat.
I can read to you the other entries in here. So we have one that says unclear cost-benefit analysis or an ROI-NPV story of heat pump water heaters.
Great.
We have a couple more. Could you clarify that the R134 does not work well below 32 degrees?
That's an easy one, yes.
And then comparable energy use savings between standard CO2 and 134A systems. And that's all.
Okay. I can say the CO2 tends to operate more efficiently, higher COPs than the 134. And cost-benefit analysis right now, super costly. So we're an emerging tech right now, and maybe Robert can help me out there. But costs currently are high.
Yeah, Cash, I can address that a little bit. So Bonneville is working to deploy some of these through our custom projects, and the ones that we do get involved in, we're doing a feasibility study looking at, will it fit? What is the ROI on it? And is this a good application? And I was going to talk about this a little bit later, but I might as well just mention it now. These products are in the market, and multifamily central heat pump water heaters are our first market, but there's a lot of other markets out there. So we are trying to do these feasibility studies in different markets as well as multifamily. And we're trying to build that, from going to the field and getting these things installed, building those ROIs and that understanding of costs in different markets.
These are some of the first products that have been installed in the United States. So especially some of the Sandins and the Mitsubishis, some of the demonstrations you're seeing here. Okay, so the 4 components of a central heat pump water heater system, did we get one answer right in the chat?
We have heat pump, storage tanks, control system, and temp maintenance system.
Yay! Kudos to whoever said that. Shout out. Who said it?
Eric Wilson.
Yay, Eric. Good job. Okay. Okay, so this next part of the slideshow is a real-life example. I'm going to pull it up, Jackson Apartments. So this is where I'm going to do something that is supposedly a best practice. I am going to walk away and let you guys look at this real-life example of Jackson Apartments. And this is where you were just in the parking garage. And I showed you the heat pump water heater system on this slide. This slide. This was Jackson Apartments. So now you're going to go and take a virtual tour of the Jackson Apartments right here. So feel free to go on your own, take out your cell phone, click here, or click this hyperlink here and go check this out. Jackson Apartments, so this is what it looked like. The system is here, so that's probably the most pertinent to this, this webinar today. So in addition to that, Robert, I don't know if you want to just take it from here.
Why don't you go ahead and introduce it, and then I'll follow on.
Sure. Okay, so Bonneville has a ton more work that we've done. So we've got multiple applications and multiple systems, retrofit, new construction, CO2, non-CO2 systems that we've been working on. And these are available on the BPA webpage under emerging tech. So this is all our emerging tech work. It's not quite yet in program. So we do run this as emerging tech, and we do run this as custom work now. But more to come. So hold on. I don't want to give away Robert's next slide. So, but there's a lot more interactive live tours. This is a great thing that we did partnering with DNR and Ecotope, and we're able to do during COVID and bring to life these virtual tours. They're super duper cool, and just really beautiful, beautiful work that were done here. And so go check this out too. More thing links, more cool work. Also, there's hard copy papers and reports here too that you can download. Go to the next slide. Is there a question? Go ahead.
No additional chat questions. I was just going to add one additional comment to yours. So as Kesh said, we've done a series of demonstration projects for these products. And we, typically in the past, we would do these technical reports and say, great, here, look at, but doing these DNR, just like you saw with the Jackson Apartments, is a little bit more of a new approach for us to help bring this out and educate and show people what's available in another format besides the report. We have several of these that we've done. I believe Bayview Apartments is one of them. HopeWorks is another one. So HopeWorks is up in Snohomish Service Territory. So these are a great way of communicating how these systems work and showing where they were actually installed. So.
And these tools are available also for you to use and share with your customers. So if you need to be able to explain to somebody else, what does this look like? How would this work? I think it's a great opportunity for you to be able to also say, well, this is kind of what it looks like. This is what I know and understand. This is what I see. Everything's different. There's a different application, but at least there's a place to start.
Okay, Kesh, I can take the next slide. So as you've heard, we've been working on this for a while. We've been working with manufacturers to bring these products to market, test them in the marketplace, demonstrate their viability, demonstrate that there's significant energy savings potential. And we're taking all that and we're now currently developing a multifamily central heat pump water heater new incentive measure. We're targeting a 2023 date for that. And we're working with a number of different folks. Some of our partners are Tacoma Power through an APA grant, working with EA, obviously ourselves, BPA. We're engaged with the RTF staff. We have support from Ecotope and others. So we're bringing all these learnings together to create our first measure in this space. And we created some of the support items along that. And so I'm sure a lot of you are familiar that NEA had created a residential water heater specification. Well, now with these new products available, they've created a commercial water heating specification. And we created a QPL for the multifamily central measure that's going to be coming up. And we've created support tools such as EcoSizer and EcoSim. So there's a lot of background work that goes into bringing this incentive measure to the table, but we've created a lot of collateral and a lot of tools to do that. So looking forward to releasing that next year. Next slide, Kesh. So we've also engaged with our customer service engineers. So BPA customer service engineers work with our partner utilities, and they're really boots on the ground out there. And I've already mentioned that we're developing a new central heat pump water heater incentive, but as Kesh has shown, there's large volume heat pump water heaters are in the market today, and we know more manufacturers are coming to the market with new products in the next year or two. So we're getting a nice stable of potential products to deploy. And, you know, these products, domestic hot water and water heating is used in a lot of different markets other than multifamily. Multifamily is our first market to really solidify and try to bring these as an incentive. But we're looking at other markets as well, and BPA is doing that. We're supporting the large volume heat pump water heater installations through custom projects. So these things can go in today through custom projects. And as I mentioned, we're not only looking at multifamily applications, but these other markets that also have different load shapes, and our customer service engineers are actively engaged working with folks to identify these opportunities, help them see if they're a good opportunity, and what the payback and incentives will be in these. So we're working through our custom projects to deploy this. Kesh, do you have anything to add on that front?
Maybe just some of the things that we're looking at, some of the other load applications.
Yeah. So we have gymnasiums with all their different shower and water use facilities, and fire stations, which are typically manned 24/7. They have also a lot of water heating and shower facilities. We have motels and lodging. We're exploring work in dairies. So there's a number of different places that this equipment can be deployed, and we are actively working with folks to see if these systems will work for them and get them tested out. There's a lot of time we have to learn about these, because a lot of these we've never had any opportunity to work in these markets. So we're learning about the load shapes in these different markets as we start to deploy across beyond the multifamily market.
And I think we're going to continue to see new products and new refrigerants. Things really start shaking it up over the next couple years. So there's going to be more and more opportunities. So if you guys are interested in doing a demonstration, definitely talk to your customer service engineers or your energy efficiency representatives or your account executives and reach out to us today. And we can run something as a custom or a demonstration and figure it out. Hopefully you guys learned something. First of a series of these sessions. Got the 4 components of a central heat pump water heater system. Those 4 components are going to be the basis of the measure. Those are the 4 components that are in the advanced water heating specification. And you have a thing link and a suite of resources to go look at. Okay, thank you, everyone.